In these questions, we're going to address domain of rational functions. So looking at number 1, x minus 1 over x squared plus 3, we're basically looking, when they ask us for domain, they're asking us what are all possible x values. So to see what x could be, one of the easier things to do is to see what x cannot be. Well, when it comes to rational functions, that means functions that are a ratio, in other words, where we are dividing, we ask ourselves, what is going to make the denominator 0? Because we cannot divide by 0. So what x will make this denominator, which is x squared plus 3, equal to 0? Well, nothing is going to make this 0, because if you try to solve for x, you're going to get imaginary numbers. So no real numbers will make this 0. If you think about it, x squared is always positive or 0. Whenever you square a number, you're going to get either positive or 0. And when you add 3 to it, then it's definitely going to be positive. So nothing will make this denominator 0. So the domain is going to be all real numbers, which is B. That's interval notation for all real numbers right here. Okay, so that's number 1. Let's go on to number 2. Let's see, what's going to make our denominator 0 here? Well, let's factor the denominator. In other words, let's set this equal to 0 and solve for it. So you can either factor it, you get x minus 2 times x plus 2 equals to 0, so you get x equals plus or minus 2. Or you could have just added 4 to the other side and taken the square root of both sides. So we get plus or minus 2 there. So these are the values that x cannot be. X can be anything other than plus or minus 2. So let's see. That means on a number line, if this is negative 2 and that's 2, in interval notation, it'll be from negative infinity to negative 2, but not including negative 2. Then again from negative 2 to 2, not including 2. And then from 2 all the way to infinity. Okay, so that's what the graph would look like. So let's see, that's C. Moving on to number 3, what will make this denominator 0? That's when x minus 7 is equal to 0. So that means when x is 7, this denominator is going to be 0. So that's what the domain cannot include. So there are several ways you can say it. The easiest way is to just say x cannot equal to 7. So all real numbers except for 7. Same for number 4. That would be all real numbers except negative 5. So x cannot equal to negative 5. That's another way of saying that. Okay, or you could do it in interval notation. You could say x can be negative infinity to negative 5, and then negative 5 to infinity. This means not including negative 5, any number other than negative 5. For number 5 is very similar to number 2. We set x squared minus 9 equal to 0. So we get x is equal to plus or minus 3. So that's what x cannot be. X cannot be negative 3, and it cannot be positive 3. That's the domain of f of x for number 5. For number 6 is very similar to number 1. You see the denominator in number 1 is x squared plus 3, so that can never be negative. Well, same thing with x squared plus 1. X squared plus 1 is always positive. So this is all real numbers. Or you could say from negative infinity to infinity in interval notation. I wanted to give us an example where the denominator is factorable. So this factors into x minus 5 times x plus 5 times x minus 1. I actually wanted to give an example where we could reduce. Well, this one we can't reduce. So anyway, I'll give you another example in a minute. So here x cannot equal to 1 and it cannot equal to negative 5. So all real numbers except for these two. That would be the domain. In interval notation, you say from negative infinity to negative 5, then from negative 5 to 1, and then from 1 to infinity. But let's give another example. Say we have x plus 5 over I'm just going to give it in factored form already, so we're not spending time any factoring, over x plus 5 times x minus 2. So although these can reduce, still our domain cannot include negative 5. So x still cannot equal to negative 5, and it cannot equal to 2. So don't get fooled by the fact that we were able to reduce this, okay? It still cannot be part of the domain. So the domain would be from negative infinity to negative 5, and then from negative 5 to 2, and then from 2 to infinity.